Hello, my name is Austin Goewert, and I'm here today to talk to you about the environmental impact of coal mining, specifically about acid mine drainage. Now, the source of the ugly orange color in the stream from the previous picture is an iron hydroxide precipitate, which is formed from the oxidation of pyrite or other pyritic sulfides in coal mine discharges. These pyritic sulfides compose anywhere from 1 to 20% of coal mine discharges. This reaction is also acid generating. Another source of acid comes from reactions of the ferric iron ion. This reacts with water, shown in the third reaction, and with pyrite, shown in the fourth reaction, to produce acid. In addition to iron, several other dangerous chemicals are present in coal mine discharges, including copper, zinc, lead, nickel, arsenic, and mercury. Taking a look at Pennsylvania, this image displays the location of coal mines in the state. The bottom figure shows the pH of discharges from these coal mines. EPA regulation for pH is anywhere from 6 to 9. So you can see from this figure that the majority of Pennsylvania coal mine discharges fall below this standard. Now keep in mind the location of these coal mines as I pull up the next image. The red lines in this image show streams that are completely devoid of fish. You can see the location of these streams matches up with the location of coal mines in Pennsylvania. An important industry in Pennsylvania is the trout fishing industry. It's estimated by the United States Geological Survey that $67 million in annual revenue is lost due to fishing that would occur at these dead streams. So local marine life can be harmed by a low pH. It can be harmed by the presence of toxins in the discharge streams. It can also be harmed by formation of ochre, which occurs when a precipitate completely covers a riverbed, killing off bottom-dwelling organisms and preventing fish from laying their eggs. This in turn will disrupt the entire ecosystem. Plant life can also be harmed by low pH and by a condition called armoring, which occurs when a precipitate coats limestone rock, preventing the dissolution of calcium. This can deplete plants of their calcium source. A study was carried out in Ohio where a group of caddisflies were released into an acid mine drainage stream and into a control stream. After 5 days, it was found that the survival percentage of flies in the acid mine stream was significantly lower, and the presence of metals in their body was significantly higher. So how do we clean up the acid mine drainage problem? The simple approach are passive treatment systems, which require no additional input once they are set up. Anaerobic wetlands involve running the discharge stream over limestone, which generates alkalinity and will precipitate out many of the dangerous metals through reactions with hydrogen sulfide. This system, however, will only work for a certain period of time before the armoring discussed in the previous slide will coat the limestone and prevent it from reacting with the system any further. Aerobic wetlands can also be used where the stream is run at a shallow depth to promote oxidation and precipitation of metals. However, this is an acid generating system and can only be used with net alkaline streams. Active treatment systems have also been employed. These involve a continuous chemical input into the system. The addition of alkaline materials such as lime, limestone, or sodium hydroxide has often been used. However, these systems are high cost due to the continuous chemical input, and they also produce a thick sludge shown in the picture here, the removal of which is a complicated problem. More advanced specific systems have also been designed, such as sulfidogenic bioreactors. These systems will precipitate out dangerous metals through a reaction with hydrogen sulfide, and by a careful manipulation of pH, it is actually possible to obtain a yield of certain metals such as copper. One pilot plant in Ohio actually obtained a 99% yield of copper from a copper stream acid mine discharge. So in conclusion, acid mine drainage is a complex chemical problem, and treatment systems must be designed on a case-by-case basis.